Conversation between Ashish and I. Ashish is, of course, the CEO of Zunum, which I believe will be the first to market fully electric aircraft available in a commercial format. Ashish, yesterday and overall in all the trades, we're seeing a whole lot about eVTOL and electric airplanes overall. I'm pleased today to be able to talking about a real airplane with actual wings on it. And I think that's going to be a lot easier with a lot fewer hurdles to get to market. And particularly as your first customer, I'm very interested in when are these things going to be ready, and what do you see as the use case?
Well, we at Zunum have been involved with electric aviation now since 2013, and we see that all of us collectively now are, together at the arrival of a new era of aviation, right? And the first such era since the arrival of the jet engines in the 1950s. And just as the jet engines have shaped the air system we have today, we see the electrics doing the same. And what we see them doing, and how we see them doing this is through two mechanisms. One is, and the most important one, because aviation is a commodity industry that lives and dies by dollars per seat mile, is an economic disruption. That the air system we have today is really driven by the gas turbines that thermodynamically need to be big to give you, competitive operating costs, and also don't like to fly off cruise, which means you don't like to fly shorter distances. And that's essentially given you the air system where over the last 50 to 70 years, airlines around the planet have migrated to larger and larger platforms, and as they have done so, they fly to fewer destinations at a lesser frequency. And in this, you're going to have electric propulsion come in and really drive a very sweeping change in short haul, because unlike the gas turbines, electrics are largely scale independent. You can get airliner-grade costs in very small aircraft, like the first aircraft we are targeting for 2022. And what that'll do to short haul is kind of similar to what you see happening today with solar and wind and the utilities, which is another commodity market that had very similar characteristics to aviation, where the traditional models of power generations needed to be large to be competitive, and then you had technologies come in that actually drove that minimum competitive scale to much smaller units. And that's the first part of the disruption. And the impact of that, many of you have felt the impact of that disruption on your journeys today. The numbers from the DOT are, if you go back and consider the journey you made to come to this conference, if you travel by air and you travel under 1,000 miles, you spend more than 70% of your time on the ground, driving to a hub, making your way through a hub, and this is something, Alex, you've spoken about a lot. And that essentially has killed the utility of air for a lot of these journeys. Right? And this has been a 50 to 70-year process. And that, in our view, has created one of the greatest challenges in transportation today, which is a gap over these 1,000, 1,500-mile distances, where you have tens of thousands of communities that have lost their links to high-speed transport, right? Expensive flight, infrequent departures, complicated connections. You have door-to-door times that have declined, even in the major metros, since the 1960s, driven by congestion, driven by aircraft being slower. And you have communities that have been dropped off have lost the connection to the global economy. And this drives us to the second impact of the electrics, which is driven by the economic disruption. You can drive then a mobility revolution by bringing cost-competitive operating models to much smaller airfields, to where you can then do journeys that are, smaller aircraft flying into smaller airfields without the paraphernalia of a hub. It's something JetSuite has been doing very successfully for a number of years in California. Now you're taking global. On the slide there, you see an example of a journey of this kind in the mid-2020s from here in San Francisco, South Bay, flying to LA, where we think your mode options at that point, and as you know, the Bay Area is roughly 20 airfields, and if you're flying out to the South Bay, you could depart from San Carlos or Palo Alto or Hayward and flying to LA, go to El Monte or Burbank. If you were to take a electric autonomous car, it'll take you nearly 6 hours to get there, and the door-to-door fare is, nearly $200. You could take California high-speed rail, and that'll shave off a bit of time, but it's still somewhere over 4 hours. Or you could fly commercial between the hubs as you do today and perhaps take a urban VTOL to your final destination, and that'll also save you time. But then if you were to fly from a smaller airfields, avoid the hub infrastructure, then you're looking at times that are roughly half. It's 2 hours, 20 minutes door to door. And over those distances, our estimate is roughly, half the cost of any of the other alternatives.
It's funny you mentioned the high-speed rail, or the so-called high-speed rail. We calculated recently that with our existing fleet of gas-guzzling Embraer 135 jets on JetSuiteX, we could offer hourly service starting in San Diego, stopping in LA, another stop in Bakersfield, another stop in Fresno, and then finally here in the Bay Area. Hourly service in each direction, an hourly flight from every one of those nodes for free for 50 years just for the construction budget, the current construction budget of the high-speed rail.
Yep.
Yeah. Now, if you did it in the Zunum, you could actually do it probably for hundreds of years just for the construction budget. If we charged $1, you could do it forever. Yep. Yeah. So what we're spending money on these days, we're solving all of yesterday's problems and basically ignoring all the new technology, which we're obviously very excited about.
So Alex, obviously we at Zunum are very excited by what you have and your team at JetSuite has been driving is really innovative service models that we think are going to spearhead the electric era. How do you see the electric propulsion powering the services you take to your customers?
For us, it's always been about ease of use and accessibility. So particularly in our new product, in our JetSuiteX product, we've got a 30-passenger airplane whose main feature is not the airplane, but the airport. We operate from private terminals and from FBOs. There's no TSA involved. You can show up 15 minutes before your flight, get on and go. And that's been revolutionary, in the market, sadly so, because it's something that really existed, everywhere only 30, 40 years ago. But we're bringing it back. And we see the ability to get that seat mile cost even lower, initially on a smaller platform in the ZA-10, and to offer that sort of service on a much more frequent basis in many, many more markets at a much lower cost. And what we really appreciate about Zunum and what first attracted us to you as a manufacturer was your focus on CASM, your cost per available seat mile, and not trip costs, but the actual customer unit economic cost. And what we want to be able to do is just provide the freedom of mobility that I think is our expectation, if not our actuality, particularly in this country. For now, just yesterday I was here in the morning, listened to a couple of the guys talk, and then I had a lunch in Burbank, drove over to Oakland, got on a JetSuiteX, had my lunch, came back, and was able to catch a dinner here in town. And that's something that is kind of extraordinary now, and certainly, by the way, couldn't be done with a train. But that's an experience that we think would be very, very routine and very cost-effective, cost-efficient, less than $100 each way, once we have our Zunums in production.
In many ways, Alex, the urban vertical takeoff aircraft, which harken back to the helicopter airlines of the past, the commuter airliners, services like yours that bypass the hubs, the electric age will, bring back some of the service models that used to exist. From your standpoint, what do you expect will revive?
Oh, microphone.
Apologies. Which of these do you expect to revive and help support your vision?
Well, initially, I think it's going to be the regional airline market. So the journeys between, say, at least 75 miles to up to 500 miles. I think will be the sweet spot. I'll leave the eVTOL stuff to people with far bigger balance sheets and R&D budgets than we've got. But I think the challenges for what we're trying to accomplish together are far less. I said, at the beginning that the Zunum has wings. That's a big distinction. We're only trying to change the power plant right now. Of course, the design is also very efficient and beautiful. But the fundamentally is still an airplane, and we still require runways. And by the way, there are 2,000 runways, that are usable, probably more for this aircraft across the country. So it's a much easier problem to solve than I think we're trying to solve with the eVTOL. and we'll probably bring in, the first era of easier and much less expensive regional transportation. That's what we're shooting for, and a lot of it. And I know there's a panel on this later today. Will be about distribution. So if we can figure out, somewhere between the Uber, car on demand at zero, zero marginal cost to the reservation provider at Uber, and buying a ticket on a fully fledged airline that has to actually employ pilots and own airplanes and take all the risk whether people show up or not. We're going to start going closer towards the asset light booking model. But if we can figure out the distribution and if we can kind of own the short haul regional transportation space, I think we'll be well positioned to take advantage of whatever technology actually is proven out when other kinds of flying vehicles do come to market.
Yeah, and we trace our history back to the short-haul air systems work in the U.S. of the late 1960s and early 70s, when the DOT was first formed by Lyndon Johnson, and they went out and one of the first charters they had was to come up with a long-range transport infrastructure strategy for the U.S. And they came back with the U.S. needs some form of high-speed rail, and they need short-haul air. And the view was that at that time, where regional air was much more developed than it is today, you had hundreds of regional airlines, and at times you had thousands of commuter airlines, that the power plant, the aircraft, and the airports were all optimized to medium to long haul. So that's a problem that we see that has persisted now since the late 60s. And it has only gotten worse as the fleet sizes for the regional carriers has more than tripled since that time. The map you see is actually one of the roughly $1 billion of taxpayer money was spent across the Department of Transport, the Department of Commerce, all the major aircraft manufacturers. Folks flew actually pilot flights in a number of cities in the U.S. and Canada. And that was their view of this short-haul air system and how it would serve the demand in the U.S., that you have the air system we have today that's really focused hub-to-hub, longer journeys, and then you have these denser corridors where people are traveling much shorter distances on average that you can support with just a very different infrastructure that's adjunct to. And the only difference for us is really that that work was impaired by just having one propulsion, which was the gas turbine. That's really not optimal for this use case. We've replaced it very optimally with what we think is a hybrid to electric platform, which starts out hybrid, giving room for battery technologies to develop, and then is still architected through a series hybrid power system to go to electric as batteries improve. So, an aircraft you might purchase that may have a turbo generator at the outset, you could, for certain missions or as batteries improve, be in a position to come back and then get that replaced with just all electric. And one of the things that's happened in the last decades is that the scale-up of the airlines has really reduced air to where around the world you have regular departures from less than 2% of the roughly 40,000 airfields there are, right? So unlike a high-speed rail or the Hyperloop where you need to dig tunnels and you need to get easements, really all you need to light these up we would say, is swap capability at minimum, which is a low-rate charge, and in some circumstances you could put in a megawatt class charger. And beyond that, what you need for regular flights is essentially what's being deployed on one hand through next generation ATC. You have next gen coming in the US, SESAR in Europe, Open Skies in Australia with GPS flight paths with ADS-B on board. And then you have, ride sharing, you have increasingly autonomous cars that sort of solve the problem of the last mile to your home.
Yeah, I mean, part of what attracted us to the Zunum is that it's an incremental approach. We're first going to there will be a jet engine on board. It'll be an APU. It'll be there to, provide some additional juice when it's needed. Charging the batteries on the ground, you can do that if you land somewhere where there's no infrastructure. recharging in flight or assisting with longer stage lengths. So we're very, very happy to have the very practical, I think, approach. You know, we're not trying to boil the ocean here. We're just changing the power plant, and then we're going to wait for better batteries, and then we're going to change out the APU, and then we'll wait for the infrastructure to catch up so we can fly to places. But to your point about, you know, Hyperloop trains, what have you, you know, the beauty about an airplane and the reason they're so easily tradable, you know, and financeable despite their extravagant expense is that they're very, very interchangeable, right? You can't take a Hyperloop to Cabo on the weekends, you know, when you take it to LA during the week. You can't take a high-speed train, you know, to Guadalajara, right? I mean, it's just an airplane will point whatever direction you want it to anytime, you know, any time of the day or night. So much more interchangeable. So I think, you know, given the incremental approach that Zunum had, and given the very, very strong background of the engineers at Zunum, and of course the backing from Boeing and from JetBlue gave us enormous comfort. I'm glad it says arriving early 2020s because you still haven't answered my first question. When's the first one going to be ready?
Well, I think last year we announced entry to service in 2022, and we battle every day to keep on that time frame. You know, there are financing with regulatory, and then some of the key technology issues we are solving on the way there. And just as backdrop to give you context for sort of the path to market, you know, the aircraft itself is an all-electric aircraft from the standpoint of all the propulsion is electric. So you've got these two quiet fans that are optimized for these journeys and for these lower speeds. They're also low-pressure fans where we are driving down pressure ratios from 1.4 is what you would find in a typical turbofan down to 1.1, 1.15, so we can get efficiencies that are better than an open propeller, but then also at the same time give you noise that's 80% lower. And we think that's hugely critical to make the far door-to-door times a reality, right? You can't have, you know, the situations we have today, for instance, in the Seattle area around Painfield or in San Francisco around San Carlos. And then this electric aircraft is essentially powered by sources that are driven onto the aircraft by operators like you, by the economics of the source and the emissions potential of the source. So in the first generation aircraft, we see you know, batteries backed up by turbo generator being optimal. And those by itself are actually sufficient to give you a very, very dramatic reduction in operating costs to where a 12-seat plane can fly 8 cents a passenger mile, where the US mainline fleet today does 11 cents a passenger mile. Right? So that's a very, very dramatic reduction. But to get there, our path to market is really sort of, there is two certifications we have to go through. One is Part 33 for the electric power plant, and that is, you know, focused on the power and propulsion, which is the bulk of our team, and across, you know, we have 3 centers. Our center in the Chicago area focuses on megawatt class electric propulsion, and then our center in Indy is focused on taking power from these electric machines and converting them to quiet, highly efficient propulsion. And the first public milestone we've announced around that is a flying testbed, roughly the middle of next year. And that will essentially start the flight test cycle of that, the electric power plant. We've run ground tests already earlier this year at full power, at low power last year. And then the flying test bed will then, we expect, go through 2 more prototypes before it goes into qualification testing for Part 33 certification. And then the complement to it is the Part 23 program, which is around the aircraft, and the bulk of that work is being done in the Seattle area, and obviously that's much more conventional programs. The challenges there really are around the integration of the electrical system with the aircraft. You know, how do you best integrate the batteries? How do you make them swappable? Because that is our primary mode, and in a way that can be done at every small airfield with minimized risk of damage to the aircraft. Most importantly, and probably the trickiest problem is really around heat. It's the thermal system that we generate. The power plant on this aircraft is roughly the secondary electrical system of a Boeing 787, and we generate a comparable amount of heat, which is 50 kilowatts, and the bulk of it is in the slender tail of the aircraft. And how do you put this heat to use? Or if you have to dispose of it, how do you dispose of it with minimal loss, increase in drag, or loss of efficiency?
So, there's a question up here I'm going to address. Is about to get to it anyway. Will we use these for JetSuite or JetSuiteX? And it's a great question, and it's actually a raging internal debate right now. Everybody wants it. JetSuite, if you don't know, is our private jet operation, and we've got mostly Phenom 100s and Phenom 300s. We've got a Legacy 650. We'll be announcing some other platforms early next year as well, which will be quite exciting. But they really want it because the seat mile economics. Everybody's sensitive to the budget, and if you got an airplane that's got roughly the same capabilities as a King Air, but costs a quarter as much to actually operate, maybe about the same to own, then you've really got a game-changing airplane. And the problem with our VLJ fleet, the Phenom 100 in particular, is that it's not super great in the mountainous airports, and it's very efficient once it's up and running, but there's a number of runways we cannot use because it's a little bit too efficient, or maybe underpowered for certain use cases. But the Zunum solves that because one of the virtues of electric power, it's not sensitive to altitude, so we'll have max rated thrust, even leaving Telluride. And so it's a much more versatile airplane, and our customers are going to want that. We've also got, obviously our customers are going to want lower costs as well. We're trying to move away on the JetSuite Inc. side from totally a cost story to a service story as well. But the first ones we're going to take could be 6-passenger executive airplanes, or they could be 12-passenger sort of regional commuter airplanes. And each of the business leaders for the respective businesses want the airplane. Inc., Stephanie really wants the 6-passenger. So she can take on the King Air operators and answer the need of our customers to fly to those smaller, more remote airports at a much lower price point. And of course, the JetSuiteX business leaders want it because they want to attack many, many more markets. And all of a sudden, flights from Santa Barbara to Burbank, from here to even across the bay, from San Jose to or Oakland to Sacramento, to Truckee for sure on the weekends, places like that. They're not quite cost efficient enough for the Phenom. Will be very, very easy use cases for the Zunum. So both businesses want the airplane, and I think the answer is we're going to split the baby. We're going to take a number of them in the 6-seat configuration, a number in the 12-seat configuration, and we're going to see which has the greatest NPV for the respective businesses. But my suspicion is that it'll work on both sides of it. So I think that we're very, very bullish about the airplane, and we think it'll be transformative for each of our private jet business and our public charter business. The question about financing sources. Actually, this is where running a private jet operation has a big advantage because the relative cost of these airplanes, while expensive for mere mortals, is very achievable for our customers. When this might be a way to reignite the old fractional business, there's a couple operators that still do that very well. But certainly, high net worth individuals that want to be the first with the new technology, I think a number of them will be willing to stroke a check to buy the airplane and take the residual risk on the airplane, just so they can say that they were first to market. So I suspect there's probably, of our 1,200 Suite Key members, there's probably a couple hundred that would take down a fraction of a Zunum. So that could be a very nice internal off-balance sheet source of financing to get these things going. And I think just the buzz alone will make that achievable. And as far as there's a lot of money looking for returns right now out there. So as far as more institutional investors and institutional financing sources, obviously we've got two multi-billion-dollar blue chip companies backing us between Qatar and JetBlue, for whom the cost of these airplanes, again relative to the platforms that they're flying, is kind of de minimis. So I think we'll have no problem financing. Call it the first 50 of the 100 airplanes that we've ordered. And then if they prove out, I think that the rest will follow. Yeah,
and this is something that we also are involved from a regulatory standpoint over the last 3 years in the US, also in Europe, for instance, around Norway, and more and more at the state level. And this is something we've taken to our legislators. There are bills in motion in DC that will, for the first time, put electrification incentives in place that are going to support electric aviation along with terrestrial technologies, which is a very significant step forward. We, in addition to that, have sort of put requests and are driving around that you need to provide support along the downstream value chain, which goes to things like loan guarantees for the first tranche of, or lease guarantees around the first tranche of these aircraft, because you do have a bit of a chicken and egg problem with a bunch of with the lessors that around their willingness to step up and take a risk on especially a whole new propulsion that given their comfort with the gas turbines over the last 40, 50 years. Yeah. And Alex, so from your standpoint, what do you see as your major, most significant operational challenges?
Well, I think one question is right there on the screen. Where are you going to find 2 pilots for each of these airplanes if we deploy them in the numbers we're talking about, and more so? That's already a challenge we face today, even with our relatively small fleet of about 40 airplanes. So, first of all, actually, you can go to about 30 seats, and you only need 1 ATP in the left seat, and if you're 9 or below, you can actually do it single pilot. So again, this is another example of the incrementalism that Zunum is employing in their approach here, because we're not looking for a self-flying airplane. We're not looking for something, and this is probably what we have in common with some of the eVTOL models. There will certainly be a pilot, but perhaps by the time it comes out, instead of the need for a second pilot, we can either do a remote land-based pilot, as many of the manufacturers are talking about right now, or just basically, a push glass to land airplane kind of button in the back. So if the one pilot you've got is incapacitated, you push the button and the airplane lands itself, break glass in emergency, which is a real thing. And in some cases would probably be better than a second pilot, because it won't be distracted the way humans can be. So there will be need for pilots for these airplanes, in my view. I don't think people are prepared to get on an alternatively powered, unpiloted airplane anytime soon. I think the day is going to come, but the day is not in the next 10 years, which is certainly a time horizon in which we're expecting our first Zunums.
Yeah, and our view really is, and this is something, we've heard from carriers now for the last 4 years, right, is around the need for any venture at this point in time to be very, very aggressive and forward-thinking around, what the pilot looks like, because everyone, and this is something we were dragged into by the operators, is everyone sees very significant change coming, but it's hard to predict exactly when that'll hit. So our approach, as Alex pointed out, really is our commitment to be starting with single pilot, and then a commitment to be amongst the first with a pilot optional cockpit, right? And to get to that journey, for the first aircraft, we are talking really about you enter the market in 2022 with command by wire. That follows within a 2 or 3 year time frame with fly-by-wire, right? And at the same time, you're then exploring aggressively, getting on that roadmap technologies that allow simplification of, the pilot activities, allow levels of remote piloting, and for certain applications may enable you to fly pilotless. So, there we are, our approach is really to watch carefully, engage with leaders in the space, and led by our operators to set up and make sure we are not locked into a corner where we miss a technology that is coming down the pike around autonomy.
Ashish, one question disappeared off of here, and it said, how big are they going to get? Oh, there it is. Yeah, long term. What's the maximum seat capacity? So I know we're talking about a 30 to 50 seater. 30, by the way, is the max we can do under Part 135 scheduled. So don't make it any bigger than that.
Yeah. Yeah, our focus is really to try and stay at the forefront of regional electric propulsion technology. So our focus is very much on ranges where we can deliver not 15-20% improvement in operating costs, but where we can deliver 40 to 60 and 80% improvement in operating cost. which necessarily is, we talk about 1,000 miles by 2030, 1,500 miles by 2035. And from our standpoint, those distances actually limit the seats you want to put in, because what we see happening is a shift away from the hubs over those distances, given by the ability to deliver passengers much faster door-to-door times, and that by itself is going to limit the size of the aircraft and is going to drive a shift in the way the fleets are developed today, and sort of you have a pendulum that swung over to a narrow body being the minimal aircraft almost, right? And for many regional operations to swing back to the past, where even as recently as the 1980s. You had the regionals in the US flying on average 20-seat planes. So, on our roadmap, we talk about the first aircraft, which is roughly 1.2 megawatts of continuous power. So that's, maybe 6 Teslas. And putting a megawatt plus up in the skies is actually a hard problem. And then in a stage way, we want to go from that 1 megawatt, 1.2 megawatt to roughly 4 megawatt by 2027. And that would be 50-seat-ish. Aircraft that's optimized by speed and altitude for 1,000 miles. So faster than this our first aircraft, but basically roughly the same sort of technology scaled up. We have done conceptual designs. One of them is on our website. That's like 100 passenger, 1,500-mile aircraft. But I think once you get beyond 50 seats, I think time will tell, right, is where, what is going to be the regional fleet. And we think it's going to be much smaller than it is today. We don't know how small.
Yeah, in ways we're kind of back to the future here. I think it goes back to Eddie Akabuchi's idea for DayJet. He had the right idea, but the wrong platform. We couldn't do it with the 2 or 3 passenger, what was that, light jet, Eclipse light jet, but his network idea and the ability for a dynamically changing schedule based on current time demands, I think was right on. He just didn't have the right platform to execute it with. So I think even with the 9-seat platform, you'll see some of those dynamic scheduling where the software will be as important as the hardware in terms of figuring out how to deploy these things, because we'll finally be at a price point where an aggregate of 3 people can easily afford, the typical consumer can afford to send an airplane in a given direction the way today only people that charter private airplanes can.
Yeah, so just there was a question there on how do you get 2 pilots with a 12-seat aircraft. We, as part of our, we've been engaged with the FAA since 2014, and one of the things we've already, it's early to be talking about operational regulations, but we have put in, set the ball in motion around 12 seats with 1 pilot, right? Because we don't see 12 seats with 2 pilots as being sort of where the economics are.
Right. Some technical questions for you here, Ashish.
Yeah, so the first question, I just answer briefly around no Tier 1 expects all electric passenger service before 2030. We would say when you look at all electric, I mean, you're which means all battery electric, you're limited in range by what batteries will enable you to do. And between now and 2030, those ranges would be, 200 miles, 300 miles, right? So we would agree if you're saying 1,000 miles in all electric before the 2030s, we would say we agree, and that's why our aircraft is hybrid. At the same time, we've been saying consistently for several years that we and the industry as a whole for fixed-wing conventional aircraft are about 5 years behind where batteries are. That the aircraft we've announced for 2022 would actually fly within 10% of the rated performance on batteries today, and it would sell today. We just need 5 years to get the rest of the electrical system, the electric machines, power electronics, get the regulate, push it through the FAA, right? So that statement is sort of a broad statement, but we would generally agree if you're saying 1,000 miles, you can't do that all electric by 2030 unless you get some crazy chemistry, pop up on the roadmap all of a sudden.
I'll take the last question there, the most recent one. Are we seeking additional partners? I think, not only are we less ambitious on the technology change, we're going incremental here as opposed to all in. I think that the other thing that sets us apart is that we do have a broad array of industry partners, and I'll let Ashish address his, but certainly on our side, well, we share one, in fact, with JetBlue. Ashish has an investment from JetBlue Technology Partners, and I've got an investment from JetBlue Airways Corporation. And they are certainly a very interested party in watching this come together. JetBlue is trying to expand its brand, across the travel ribbon, as they call it. And so I think they see this as a very interesting experiment. Then obviously we've got a natural gas producing nation in Qatar, very interested in the future and what their future looks like when we sort of wean ourselves off of fossil fuels in the coming decades. So they're also very interested and also very capable of making substantial investments if and when they're needed.
Yeah, and I mean, as all of you are very aware, an aircraft program and a propulsion program, it's a team effort. And, that's one of the reasons our aircraft is a 540-volt aircraft, so we can, engage the very extensive aerospace supply chain. So this is an activity we've been driving for almost a year, we've engaged at this point with pretty much all of the engine majors, to identify a partner for the turbo generator, which is a very critical component of the aircraft. We've also have engaged very broadly across the sector for aerostructure partners, and then partners for a lot of the secondary systems on the aircraft. These will be all electric, and fortunately, all electric systems are available today for most secondary systems on this class of aircraft, except for the cabin compressor. So, I think you'll see announcements from us in the coming weeks and months that actually speak to some of these development partners. At the same time, just as in the case of urban air mobility, you need a number of things to happen downstream to drive it at scale. Leasing is one. We are very keen to engage with leasing partners we realize there's a long journey for them to underwrite a new risk. And, we want to be as helpful as possible. We want to engage with partners that have an interest in airside infrastructure and airport development or FBOs. That again, there are long cycles to these investments. In some cases, you need technologies developed, and we are very eager to help make the case. So when services begin, many elements of this chain are in place.
There is a Tesla supercharger right next to Love Field, by the way, in Dallas. I don't know if you can roll our video. We've got about a minute left here. Ali, anything else you would care for us to address today? You pick one.
I suppose you've sort of answered the no tier one answer one.
We can roll the video without the sound.
That's a nice one. Why not take an existing airframe and re-engineer? Ashish.
Yeah, Roy, why not? Roy Garzanski's back there is doing exactly that. I think you're going to hear from him later today. I think that would lower the risk, and maybe that's an interim step between where we are and where we're going. But do you want to take that?
Yeah, I think this is where folks are obviously necessarily very excited by the electric propulsion and what it does. But when we look at our operating cost reduction, just under half of it is coming from the electric propulsion. The remainder is really coming from designing a truly range-optimized aircraft, where today's aircraft are primarily over-designed for the ranges because they fly, because they typically, a narrow body designed for 3,500 nautical miles is 80% of their departures would be to 1,500 miles, so they're very heavy aircraft. We would be able to deliver to you less than half of the disruption that we can now by actually, doing a white sheet on the aircraft itself. The other part of it is sort of, if you do re-engine, there's a fair amount of engineering effort, and then you have to certify it for every platform you re-engine, right? So we just, it's just, the ROI on that gets quite complicated.
Right. Thanks, Ali.
Any traditional questions in the audience? Yeah. Okay.
Go, Henry.
Okay.
Oh, okay.
Good morning. Question regarding the fully electric power. You'll be using lithium batteries. Lithium batteries, they're very sort of volatile. Once they start, in case there's a short, or once the fire started, they're extremely difficult to put off. They're almost, it's not like you're on the ground, you can just jump out the car. Have you put any thought about, in case there's a short or something, or over discharge, how would you stop that lithium fire? And also, one more recommendation for the whole audience, probably traditional airports are not equipped to put off a lithium fire. And probably if we're going to start have operation like this, we would need to have the airport consider invent a new way to put away lithium fire.
No, that's obviously lithium fires is a nightmare for most of us in this room around electric propulsion. At the same time, when we first started talking to operators like Alex 4 years ago, that was when you still had some of the Tesla fires, and we went into these meetings expecting for the entire conversation to be derailed by concerns around battery safety. And to be just very, very not making this up, it actually never came up in a single meeting. And to the extent that in pretty much every one of them, I turned around and I was like, why didn't you ask us? I mean, we came here with all this material on how battery technologies are developing and all the investments that are going into it and all the SAE safety standards that are supporting the batteries, and why didn't you? And their view was, by the time this aircraft is in the sky, the auto industry is going to have to solve this problem, right? And sort of that is our approach, is we look across all the chemistries that are available. There are, even the more traditional lithium-ion chemistries are much safer now than they used to be many years ago. And the auto industry, and if you look at their SAE standards, are extremely robust standards that we have been engaged with the FAA since 2014 on how do you adapt the state-of-the-art battery standard and bring it to aviation. That enables us to use best-of-breed safe battery modules from auto in aviation, so we can take advantage of their very fast pace of development, so we can take advantage of their scale and pass the lower cost over to our customers.
Yeah, I mean, 100 low lead is pretty volatile too. We're in the business of managing risk, not eliminating it. So I think provided that the engineers nod their heads, we can avoid an untoward event.
Yeah, and you'll see that in some of the, we have a live trade around where to position the packs on the aircraft, and that's a very important factor, right? Is how do you integrate so you mitigate whatever risk that.
Let's give Henry a shot. We have to go.
Yeah, sure.
I'm just curious, for the scheduled airline side, turn times are very important. How long will it take to, if you will, refuel, recharge one of the Zunum aircraft in scheduled airline operation?
Yeah, this is something we heard from, and for a 9-seat aircraft or 6-seat business jet, we've heard from operators, they would turn them typically in 10 minutes. So we've always worked with a 10-minute turnaround requirement, which is why, our primary mode is swap, right? Our assumption is you have packs on board. We are looking at 3 different integration scenarios, but all of them have to be designed to be quick swappable, and that then allows an FBO, for instance, or an airside operator to actually have a bank of batteries that are sitting, that perhaps are charging at lower rate for longer life on the batteries, also balancing the grid and taking advantage of lower pricing. And the reason that works versus automotive is that for our aircraft, batteries are less than 2% of the selling cost of the aircraft. And so when we run economic models for our operators, we actually factor in multiple packs per aircraft. And that's obviously very hard to do with autos where 30% of the cost of the auto is the pack.